Hanyu, the founder of Shojinmeat project and also the CEO of Integriculture Inc. Well, Integriculture is the first startup coming out of Shojinmeat project. Okay. So, your Shojinmeat project is a citizen science for cellular agriculture. And so who we are? We actually citizen science movement for cellular agriculture, and members consist of scientists, researchers, students, and science communicators, artists, and high school students as well, kids as well, and people with different expertise. So they work on the different fields. Some people are working on law specialists are working on the regulations, that kind of thing. There are the group of people in Kyoto University working on ethical studies, animal welfare, kind of things. And I'm more into R&D and commercialization cluster. And this is kind of some of the select pictures of what we do. That one on the left, he's basically selling our cultured meat fanzine in a Comic-Con, as a comic market. And that's basically the how to grow meat at home fanzine. We're actually selling the only 3 left there, but anyway. And the one on there is a laser point here. She's a high school student. She's basically growing meat at home. And he's an artist working on speculative design, and that's the speculative meat culture setup for apartment buildings. So every morning you go down on the ground floor, open that thing, take your own meat, go back up. And that's the sample of the culture, the meat I grew at home. So that's basically based on freeze-dried cognac, which is kind of like a glucomannan cellular scaffold that you can buy in supermarket. And we basically grew chicken cells on that. And that's cultured foie gras sample we made. And we had a party, and we just basically split that into 6 pieces. So it wasn't big, but we could still taste it. And that's the sample of what we call, it's still clean meat, but it's also a green meat. It's algae-loaded cultured muscle cells. And that's the video of us growing meat and also eating it. It's all filmed, so people basically watch that video and replicate that at home. And yeah. And why are we doing those things? So, because there are different sorts of people, with the motivations vary, and some people are working as passionate about cellular agriculture, out of sustainability issues, and this is more for me, but for people with dreams of the future. And also there's people who are concerned about food security, and it's also a common argument in East Asia, where especially in Japan, most of the food is imported, and so is in Singapore or UAE, so the food security is a huge issue there. And especially in countries like Japan, where animal welfare and that kind of, those arguments don't really sell well, it's actually the food security that people do care. And there are also people who are working there for pure fun, and that's out of an anime in which cultured meat actually appears, or at least the rumor that must be cultured meat, and so we decided to actually make that. But anyway, but if we were to actually do that, as we all know, there are hurdles, like technological hurdles and social hurdles. And obviously for technological hurdles, it needs to be bigger and cheaper. And for social hurdles, it needs to be understood. So the stuff to do for technological, let's biohack. And for social, well, let's talk. And when it comes to let's talk bit, the agenda surrounding the cultured meat varies quite a lot according to regions. And as an only seriously active cellular agriculture team in entire East Asia, we are kind of working on how cellular agriculture and cultured meat fits in East Asian cultural context. So such as how Zen Buddhists see clean meat. And also we're working on those ethical studies and animal welfare kind of argument in joint sessions with Kyoto University faculties. So that's one of the things what we mean by let's talk. And other than that, we're also sort of like doing like consumer acceptance thing, but I guess there are other groups working on that, so you could leave that to them. And so when it comes to, it needs to be cheaper and bigger bit, we're taking the DIY bio and biohacking approach, and the reason is, especially this is effective for, it needs to be cheap bit. It is accessible, transparent, and low cost. That's how the DIY bio or biohacking works, or otherwise it's just not biohacking. So accessible, what we mean is you can do it too. And in fact, high school students are already growing meat at home. And transparent, and it's all on the web. So you can actually watch our video and replicate that. And also it has to be low cost, or otherwise, we can't really do it at home. So where do we do experiments? We do it everywhere, basically. So that's Lebanese. It's a kind of an education company. They do like Sunday science schools, Sunday science classes, and they do have a teaching lab, and that's where we do cell culture experiments, some of them, and also homes and kitchens, obviously. So that's like microwave, and that's toaster, and in between there's a meat incubator. And actually, when I did this experiment in my bathroom, my parents were not very happy, but but I did it anyway. So that's how I made my like cell culture medium out of like dog food. And also we have a place called Fab Cafe Tokyo. It's a makerspace Fab Cafe in Tokyo, and there's a small lab right next to that, and that's where artists are trying to grow meat. And recently there's an artist, but she's more interested in the like DIY cell culture aspect. So she's not growing cow meat, but she's basically culturing her own meat for whatever purpose, I don't know. Yeah. And also we have this is kind of like a starting, we're starting a new project with this Twins Lab, which is the tissue and organ factory, and it's a joint research facility of Waseda University and Tokyo Women's Medical University, and that's where the regenerative medicine research is going on, and also that is where the heart muscle cell sheets are being grown for medical use. So it's a proper laboratory, and as a biohacking, so if you look at DMEM, it's basically sugar, amino acids, and some minerals. That's basically sports drinks or Gatorade. So we actually did it. So we tried 15 different sports drinks, and because it's in Japan, you can just go on street and you can see lots of vending machines. Just buy any one of them. Tested all the osmolarity and pH, and adjusted the pH and osmolarity, and actually tested it, and unfortunately we couldn't get it to 100%, but we still managed to get 60%. Replaced 60% of the demon replaced with sports drinks. And also for FBS, which is a huge problem. So, but if you look at the cut log, like by Sigma Aldrich or something, you see there's something called yeast extract from animal cell culture. So it's actually not a brand new idea. So we basically decided to, well, let's make this. So we did it. So dried yeast, which I found later that it's actually also a dog food. But we basically convert dog food into cell food. So do that experiment and mix with papain and digest that into amino acid soup, and then we basically made that. So preparation cost is about 10 cents per liter. It's a lot cheaper than buying an FBS. Yeah, but the bad news is it has got limits. So we've tested different cells, and it seems like it has got limits, especially in undifferentiated cells. And so which includes myoblasts. So we can say that some growth factors are missing. So then another biohacking time. So how do I supplement those missing growth factors? And that's what we are doing. So people talked about co-culturing, and that's actually what we are doing. So we basically developed this network culture system. We call it CULNET system, and what's happening here is this is one of the uses. So we take this placental cells, which releases the HGF and EGF and those things to grow liver cells, and those liver cells can actually help grow the muscle cells, and whatever coming out of muscle cells can also help grow these placental cells. So this is in short, this is kind of like a general purpose large-scale cell culture system. So using that, we did actually make a clean foie gras. So grow liver cells and fat load the cells, and then basically make an aggregate out, and we basically produced about 1.5 gram of that, and did a party, splitting that into 6. Well, we also had other nibbles, so. So having said that, so after doing all this, so how cheap did it get? That's another big question. So it's at least it's coming down because we are not using any we are not adding any external growth factors. So it made it a lot cheaper. But cells, it can be like muscle cells or liver cells or many different kinds of cells. And so we found that there are difficult cells and easy cells, and the price ranges are somewhere around here. So what we are doing now is make as many difficult cells into easy cells as possible. And after that, we can talk about scaling. And this is more of a, rather than Shojinmeat project, it's more of a like Integriculture, the startup thing. But if we had to make it into a like market, which is like that, like meat, which makes sense only if we can make it at like $6 per kilogram. So we probably start with supplements, and then come down to foie gras, and then designer meat, and then reach there. And these are the expected like break-even figures. And what's sort of interesting is what we call designer meat, because if we are actually culturing muscle cells, we can actually do like beef pork mixed meat, which we don't really know how we call it, but yeah. And also we can grow meat that doesn't have any allergen, or maybe like reinforce it with certain nutrients. And that's one of the examples of like green meat rather than clean meat. And that's basically layers of algae and muscle cells. So grow muscle cells, on top of that like layers and algae, and then further top of that we have like muscle cells, and also these algae and muscle cells are in kind of like a symbiotic relationship, and these muscle cells, they sort of pee, they release like ammonia, the kind of thing, but those algae basically eat those things and release back the sugar and those things. So it's kind of like a symbiosis of animals and plants going on at cellular level, and we call it like sort of superfood algae-loaded designer meat. And further down the road, so this is what's happening in the like tissue and organ factory in Twins lab, and right now they're using it obviously for medical purpose, but they basically have the best tissue engineering technology there. So what we are planning to do is basically combine our method of like biohacking and cheap culture media and all those things with this kind of like medical technology, and do that at low cost. So I have to say that these figures, not at these figures, but this is how the demonstration is progressing. So that we can already do it. So it's just cell culture, and that clean foie gras we did it, and the designer meat, the green meat kind of thing, is sort of like a prototype, and that we are working on that in Twins lab. So with these in plan with the Integriculture is on the seed round fundraising. At the same time, we're trying to we're trying to make these figures, these like $3,000 per kilogram 40 or something, more like meaningful by actually doing it. And if we can do it, then that's the sort of the thing we're looking into. So the spinless people are there, but obviously the technology can be used for like brewing seafood, because it can be used for fish cell culture or the animal cell culture. It's actually very similar. And also we have a high school student member who's working on sea urchin and seashell culture in his refrigerator. And that's the meat brewery, so it can be done, it should or can be or should be done in huge scale. And also, if we do it at that kind of huge scale, we have to think about where to source this culture medium. And as some others have suggested, it will be like algae. So that's algae ponds producing culture medium. It's fed into these towers where it has got all the vertical farms and meat culture tanks are in here, and whatever waste coming out is coming back here, treated and turned into the culture medium again. And also it can be like very close to a city. And if we can build a whole packaged system, then we can just take it to Mars like that. And that's actually what I want to do. Like how many years until Elon Musk launches his rocket? 11? Yeah. Whatever. So if we can do it, that's another idea. Yeah. Yeah, probably I watched way too much of Robotech and Gundam and those things. They need these things. Yeah, but anyway, these are all, well, for now, fantasies. So before that, we had to think of more realistic things. So we're running the Shojinmeat project, the Integriculture, at the same time, but that is for reason. And if you look at what the market is like, we have certain huge amount of so-called general meat, and we have very, very long tail segment of very specialized meat. And especially when it comes to designer meat, there will be people with specific needs, and also there will be people with specific religious needs or dietary needs and those things. And we're thinking of Shojinmeat projects should probably, or the citizen science non-profit kind of people will be focusing on here, and this Integriculture will be scaling the least personalized, highest number in demand kind of meat. So the way we look at the technology and how the IP should be organized is basically how to make should be open, and we already made it open. You can just access our video or the funds in there, but how to scale it can be proprietary. But for this thing to work, actually, we need some legal assistance, really. But also, we are looking into Creative Commons, but that's discussions to be done in the future. Yeah, so this is how we look at when we talk about democratized cellular agriculture, which may sound sexy, but what is it really? So this is the way we look at it. So normally how things used to work is that academia hints the way, such as Professor Mark Post's work was one, and there are also a number of works going on over how to get the growth factors and how growth factors work and those things. And then after that, businesses scale and deliver. This used to be done by large corporations, but how GMOs failed was basically after academia working out the way, they basically jumped straight into businesses scale and deliver, and then got into all that anti-GMO thing. But if we have the Citizens Act and set the direction in between, basically, so we have that and Citizens Act, and if they can set the direction, we should sort of have a social consensus. Although even if it's not 100%, we should have a general direction, and that's where citizen science can actually set the way things should go. And then after that, the businesses can scale and deliver. And this is one of the things we've already done. So, so what sort of direction we are setting? Well, teens can do it. And that's basically high school student growing meat in her place, and that got televised nationwide on August 21st. So who should be claiming the space for the cellular agriculture? What we are thinking is that basically it will be these sort of people, youngest generation, because they are the ones who will be actually eating clean meat in the future. Yeah. Thank you very much.
So I'm going to pull up Slido really quickly. If I actually have it up, I might not have it up. So I'm going to wait for it to come up behind me on the board because my Wi-Fi is not working right now. One of the questions that I saw is, so I really love this idea of citizen science being a key component of driving this field forward. And one of the most interesting things about it to me is it sort of brings that sense of play and discovery and excitement back into biology and back into the biology of cellular agriculture. One of the questions I remember being asked was something like, how, when you're doing cell culture at home, do you keep it clean? Do you keep it sterile? You know, that idea of play is very important, but how do you keep it, contamination-free?
So actually, if you look at egg white is actually a natural antimycotic, and it's also quite commonly used in food industry. So it's almost like a 70-year-old knowledge that egg white can work as a antimycotic. We just use it. So 5% egg white in cell culture medium, and you don't get like molds coming out.
Oh, nice. That's good to know.
Yeah.
Okay, another question. How do you reconcile open source biohacking principles with the need to develop protected IP to attract investment for scale up? Do those necessarily have to be separated the way you showed on that graph in the long tail, or how do you reconcile those things?
Actually, that's where we need legal assistance. So, but in general, what we want to do is how to make it open, and how to scale it that can be proprietary.
Okay, excellent.
And how exactly do that? Creative Commons is a possibility, but we have to look more closely into that.
So, key question: will you share your DIY recipe for culturing meat?
Yeah, it's already on the video, and there's also on the fanzine, which is written by high school students. And those fanzines, so high school students did one at home, and now they are teaching how to do that to middle school students.
Nice.
Yeah. And probably after that, next stop, primary school. And
that would be amazing.
If cultured meat is something that even primary school students can do, then why should you fear about that?
So in that vein, with students, especially younger students or biohackers, DIY biologists, what are some of the most interesting or unexpected questions you get from them about cellular agriculture?
So the thing is, when they learn how to culture cells at home, they start testing all sorts of cells that we've never even thought about. And sea urchin and seashells were one, and doing that in a refrigerator was another.
So do they have concerns? I mean, you tell them to keep their cultures away from their food at home, or eat it all at the same time?
Well, I would say, yeah, let's do it.
All right, and I guess one last question. So what has been, I'm not sure of the context of this question, but what has been your worst experiment?
Worst experiment?
Yeah, I guess open to interpretation what that means.
Yeah, worst experiment. It can happen in different ways, but I would say like worst as in like not funny worst and funny worst both can happen.
Yeah.
Yeah, and not funny worst is the serious contamination issue because the cell culture system we're using, it's a like closed circuit system, but which means if we engineer it in a wrong way, if you get contaminated in one vessel, it basically spreads to all other vessels and basically crushes down the whole system. So that was a very bad experience and worst experiment, but we have to go across that kind of thing. And when it comes to worst, as in funny experiment, that's when I did an experiment at home, and my mother wasn't really aware of what I was doing and knocked over one of the handmade bioreactors, and it was kind of like, it stunk. First of all, it stunk, and also it was sticky.
Well, thank you so much for that.
And the worst of all, it happened on the carpet.
Oh my God. Yeah. That's what I'm thinking about. Well, thank you. Thank you so much for sharing that story with us.